Okay.
Don't move.
We leave it like this.
Don't breathe.
Nice. Okay, so where were I? We have the patch, and we don't really need a naming convention like this. It's up to the developer. It doesn't matter. We can see in the repository there is a new version. When you see there is a new version, maybe you get a notice there is a new version, and you can choose to update. You can choose not to update. You can have auto patch. Probably that's a staging environment. You don't auto patch to live environment, right? So sometimes the bad actor, when we see I'm the bad actor today. I'm regularly a pretty nice guy, but today I am the bad actor. Remember, it's in character. I'm the nice guy. And what? Ah, okay. I stand really still, like this. No, not like that. Like this. When we, the bad guys, when we see there is a patch or an update to the software in the repository, we can scan it. We scan it. We can see in the changelog if it's security related or not. Sometimes we don't even have to scan the changelog. We get an email. Oh, I can't switch. Yes. Sometimes we just get an email. And this is an email I got from this year with a recent security patch from a software that I'm running. And the email says this is a security patch, and we should update now. And the tell it is a critical security patch is kind of it is a mandatory security update, and that we should update immediately. But as bad actors, we don't really need the email. It's just a funny tell that it is a critical problem that we are patching. And this is the actual patch diffing I'm doing today. Writing the exploit for. And in the timeline, we are here. And before the patch was released, there was a vulnerability found, right? After that, the vulnerability is reported. They work on a patch. The patch is released. And somewhere in the future, you guys apply the patch, right? And the time between the vulnerability is found and the vulnerability is reported, that's the 0 day. If we are not the founder of the actual vulnerability, we will probably not be in the 0 day space, right? However, we can aim for the 1 day. As bad actors, we can aim for the 1 day by doing patch diffing, and that's what I'm doing today. So, we have this one. Point in time, we cannot see. There's a red. Maybe I can do this. No. Maybe I can do this. Laser pointer. Here, there is one more red one, and that's the bad actor finds the 1 day. That's where we start. So let's put it a little bit bigger maybe. Is it big enough? No, you don't see it. Let me end this one. Can do this. Now you see it. You want me to move it up a little bit? Maybe like this? Is it better? Okay, so I have a directory prepared here for this talk, and I will probably copy it because I'm doing this live. I can screw it up. I'll just do a copy of it. I don't have CA because it's called CP, right? Can't have it really that big. Yeah, now you see it. Okay, so I have the original software. That's the software you're using. And in the repository, we can see there was a patch. Also, we got the email. We didn't need that. I have some helpers if I get blackout. And also, I have the SC zone file. I got that from IIS by saying, I'm your backup DNS. Works like this. I did an AXFR request to IIS zone data and said, I am your backup DNS, please give me the entire zone file. It contains about 8 million something records of DNS data. And I extracted only the domains, so I cut it from tab and space, just to give it only the unique domains in their own file, right? So I have about SC domain. I have about 1.4 million SC domains, and I think it's updated once per hour. So if you have SC domains that is newer than 1 hour, you're safe. But otherwise, you're in my list here. When we're doing a patch diff, the main strategy is to compare the original source with the patch to understand what was patched, so we can write an exploit that works specific for this software. And I have a tool for that called patch differ. I created it. It's on GitHub. It's not very sophisticated. I'll show you how it works. Basically, it takes 2 arguments. It takes the original software, and it takes the patch or the entire software in the patch state. And then it will tell you what's the difference. So we do it like this. That's the patch. We run it, and it will tell you we have a total of 15 modified files. So I don't have to go through all the source code with thousands and thousands of files to know what was patched. I can just take a look at what was changed. And this tool will give me a new directory on my file system called diff. And if I show what's inside that directory, I have 2 new directories. I have a mix directory and I have a patch directory. In the mix directory, I have those 15 modified files together with any newly created files. However, the modified files are not in the modified state. They are in the previous unpatched state. And I use that for searching. If I want to search the source code for potential problems, I do not want to search in the patch, right? I want to search the original. That's why I'm having this mix directory. And then we have the patch directory, and that's basically a local Git repository created by the patch differ with 2 commits. Where do I have it? Patch, right. So if I do git log in this one, I'll see I have 2 commits. I have the original commit. That's the 15 files that was modified in the original state. And then I have the patch commit. That's the 15 modified file in the patched state together with any newly added files. And that's where we want to start our investigation. And we don't need to be genius to do this, actually. So these assets, that's client side. We don't really care about that right now because we're looking for a severe security issue and it's probably not present in the CSS, right? So we're going to delete that. We're going to delete the git ignore file, and we're going to delete the languages, and we're going to delete the style. Like this. It leaves us with a lot less to investigate. It will go a little bit faster. But if we start here, what happened in the patch and what is really nice and convenient with to have a local Git repository is that I can have them side by side like this, and I can see the changes. Can you see the changes? Yes. So on the left side is the unpatched state, and on the right side there's the patched state. And if it was removed, it is marked in red, and if it's added, it's marked in green. So I can see the first change is just a change of the name of the query filters. I don't really care about name change. I'm probably looking for some authentication errors. I don't touch it. You're doing something? Okay. Nice. Okay, so is it large enough so you can see? Yeah. So on my right, I'll just play some royalty music while we wait. Okay, so at the right side, I can see where's the difference. Do you see my scroll bar at the top right? It's there. I can see there is a change. And if I'm really careful, you can see at the bottom right, behind the Mulvad boxes, there is another change. And I can scroll down to that. I know in between those, there are no changes. I can scroll down here, and I can see they indeed changed the name of the query filter. I can see they added a condition here, and I can see they added a parameter. But at first look, I don't really think this is what we're looking for, right? So by looking at the files as well, we can see there are two files here that we are really interested in, because AJAX and API changes means we can probably send the data to this, right? So when we're doing the patch diff, we are looking for interesting things, and when we find interesting things, we just take notes, and maybe we come back to them later. But what we have found so far in the admin file, we don't really care about. And we take a look at the AJAX file, and we see they have a change in the verify request function that is basically just another way of writing the same code. So they have a post ID, they are checking if this is empty, and there are two options here. And this is just a shorthand operator to do basically the same code, so I don't have to view it, I don't have to spend any time on this. I can just continue to scroll on to see if I can find some real changes. And here's the first bigger change, right? In the render element function. Now I'm very curious. So what I'm looking for is changes in authentication or something like that. And I can see here that if it's an AJAX call, they do the self-verify request. That was the other function we looked at. And I might want to take a look at that. If I had more time, I might just check what it does. Now you just have to trust me. We can't bypass the verify request function. It's not what we're looking for. If I scroll down, I can see changes in the REST API call as well. I can see in the unpatched state, as the attacker here, that's the state I'm assuming everybody is running, because I'm really fast at patch diffing. Thank you. So I can set the loop element and element from the REST API. And what is very interesting is that they deleted this in the patch. There's nothing there. However, in the AJAX call, if it's not a REST API call, if it's an AJAX call, they still have the self-verify request function. So probably we're not looking for an issue with the AJAX call. But there might be some interesting things in the REST API call, right? So we don't have to be geniuses to see that they deleted this. We take notes about this is deleted. It was in the render element function, and we continue. We see they have the same shorthand operator change. And this is also a change we don't really care about. They check if it's set, and I think they just have this also a little bit shorthand. However, the function that did not have any verification stated in the comment above, did you see it? It states in the comment that permission checks is checked in the API render element permission function. And we see changes here. We are interested in see why did they change this. And the next file is called API, so probably we're going to see something in the API file that is tied to the API permission function, right? So there are still changes in the render element. However, this is just some defaulting. They handle default settings better in the patch. However, it's not security related. But we can see the function we're looking for is present right here. And they did change the function that they said is in charge of the security permission check. And what did they change it from? What did they change it to? Because we are very interested in this when doing a patch diff. And obviously, they change it to some code that is very easy to read. Capabilities check for if the current user has no access, it will yield an error. I can read that, Most people can probably understand that. However, in the unpatched state, we have a result of verified nonce. Nonce means number used once, and it's not really for permission or credential checking, right? Nonces are mainly used for cross-site request forgeries, and there is no really permission check tied to this nonce. However, it seems that that was the only check that was done, and the default policy in the unpatched state, also in the patched state, is true. So we can say that this render element permission check have two possible outcomes. They can return either false or true, and we're just going to give our best guess that true is the one we want, right? So if we can have this result to become true, we can bypass this if statement that returns the error. Then the default policy is true. However, we can just render element. We cannot execute code, right? Do you see any elements that we might want to render to get remote code execution? I do. Let's take a look at it real quick. They removed the placeholder. We don't really care about that, right? They added the placeholder back in with a sanitation check. But if we do this patch diffing real fast, you do not implement the patch, right? This is a race condition. We need to do the patch diffing before you can patch. Do you guys know the median time to patch? Is it 1 hour? It's 60 days. 60 days or above is median time to patch. So I have pretty much time to do the patch diffing and write my exploit. And I can start attacking sites before a lot of you guys patch. And we don't really need to be very sophisticated hackers to pull this off. Actually, I think we have enough information to try this out. We have a render element function. We have a code element that can be rendered. Probably it will be executed if it's rendered, right? And we know that the only verification check that is done is the check of the nonce, numbers used once. This is also a fail because the numbers used once in this software is actually valid for 24 hours, so we can reuse the same nonce. But that's another story, and it doesn't really matter for us because we can grab it dynamically. So we could change it for every request. However, I think we don't need to take a deep dive into the source code to pull this off, because we can try it out. We have a pretty good idea of how to do this. I think an easier way to understand how this works is to just try out the actual software, because the software we're patch diffing is a page builder for websites. And if we just try it, sorry, take that away. If we just try it, we go to elements and search for code. We find the code element. We can just drag it in the builder. However, I've already done that. I have the code element here. You see it? Yes. And if I push it, I see that it is this one, and I have an echo statement running PHP code saying, hello, remote code execution. And I want to know how this works behind the scenes. I have a pretty good idea of what functions or what capabilities that I can bypass, but I want to see how it works. So if I just change this to something else, like add a 1, I will see when it renders. You see it updated on my screen, and it also sent a render element request. I don't need to dig into the source code to see how this works. I can just use the application. And if we start with the actual payload, that's what the original application is sending to the server. We can see that they are sending kind of what we expected. They're sending an action called render element. They are sending the element. That was what we found in the code, right? They are sending the nonce and the post ID. We can see in the response is a JSON object with data and HTML, and the HTML contains our rendered PHP. So this is what we're going for. But we don't need to understand how any of this works either. We can right-click, we can take copy as curl. And I think curl is not as nice to work with when writing exploit as Python, but we don't need to understand how any of that works either. We can just use the curl converter, we can paste it, we can choose whatever language we want to translate this to, and I choose Python, I scroll down, I choose copy to clipboard, I go back to my terminal, I go back out, and I start writing my exploit. And I just copy it, and I will try it out. You don't see? Oh, sorry. And it doesn't help if I make it bigger, right? Okay, so what I did, you saw the curl converter? Oh, you didn't? Okay. Okay, so this is the curl converter. It looks like this. You saw the copy? No? If I go back here, you saw this? Yeah. So I went here. I said I don't have to understand how it works. I can copy as curl. Does it show? Yes. Copy as curl. And I go to curl converter. I paste it. Yeah, I just paste it, and this is what I get. Somebody is really do not want me to show this. Okay, I scroll down, stay with me, copy to clipboard, I go back to my terminal, I just created an exploit. Let's remove it. I'm not touching anything. It's not me. Okay, just wait. Do a little dance while I wait. I only have this one and that one. I think this one is more appropriate right now. Okay. Okay. So Vim exploit, that's the only thing I need, right? Now I'm in Vim, it's an empty file. It's gone again. You tell me when it's gone. See it? Yeah. There's just a shebang line. I can remember it. I paste the Python I got from the curl converter. I didn't write it. I close the file. Yeah, it's still there. So am I? Yeah, I'm back. We need to print the result. That's the only thing we need to add here. So we print response.text, if I can spell. We try it out. And you see, we can have code executed in our local installation with administrative privilege. So we don't have really much use of it right now, but we could copy the command and we could see that it works, right? So now we can modify it. Let's just copy the cookies. Are you with me? Yes. So the cookies is what makes me an administrator, right? So I delete those because I don't have that on the live environment. We don't need the headers as well. We just remove them. And we are left with JSON data. We don't really need all JSON data. We can remove this as well. We don't need to understand how it works. We can just delete the shit we don't need, like CSS. And we are left with a pretty small exploit script. We can set anything in here. We see they didn't check if it's a valid post or if any ID is valid. And to prove it, I'll do something like this. I'll change this ID to something like this, and this to something like this. And I change this one to 2. And I'll remove the, oops, not cancel, please. Something like that. Now it's unauthenticated, right? Will it work? You can't see? No, you didn't see. I removed, you saw this one? Yeah, okay, so this is the only thing I keep from the Python converter, the curl converter. It's back? It's every couple seconds. Every couple of seconds, okay. But what I did was I removed the cookies that made me an administrator. I removed all the headers because I don't need to send them. And I removed some CSS and some styling that was sent with the request we don't need. And we are left with the smallest thing we need to send a request that will work with this patch, right? However, if we run it, I asked, do you think it works? Well, probably it doesn't, because otherwise I should not have asked, right? We have an error message that says that the cookie check is invalid. You remember that was the error message we looked in at the code. And why is that? Because we have a valid nonce. We just tried it out before removing the administration cookies, right? And the way this works is that the nonce is actually tied to the logged in administrative user. So if I do not send the administrative cookies, I cannot send the administrative nonce here, because it will no longer be valid. It's only valid when I'm administrator, so I have no use of it. So I have to delete it like this. However, you see, yeah, we don't need an administrative nonce, remember? So if I go here, from non-authenticated state, this is my incognito view. Oops. I can check here. And the nonce is present. However, it's not the same nonce. This is the logged out nonce. It does not check for credentials, right? Obviously. It's for cross-site request forgery. Remember? So if I copy this nonce from the logged out state, that nonce will be valid in the logged out state, and I have remote code execution unauthenticated on my local installation. However, it's pretty useless to attack my own local host, right? So I import system and regular expression. Pretty stable? Okay. The only thing I'm doing now is I'm making it more dynamic, so I can use it to attack other sites than my local host. So I'm basically just taking arguments from the standard input, from the arg value. So the first argument will be the host, the second argument will be PHP, and we will not put the nonce in manually, so I have to create a dynamic function to grab it from every site that we want to hack. SC sites, remember, you gave me permission to try this out. So let's do response. We know the nonce that is not logged in is present on the index page or any page running this software. So we can just do a Python a GET request with the help of Python. And then we can put the match in a regular expression, if I can spell it. Not like that, but like that. And I think we can get it with something like this. Did I do that right? Yeah, I think I did that pretty right. What I did was I'm getting the response from the index page, and then I'm putting whatever this matches in the match object here, and I'm doing a regular expression that says look for this, and then accept anything, non-greedy please, and as soon as you hit this, stop. And then I will have the nonce in the first group. The first group of regular expression is this, right, in between the parentheses. So if I did this right, I will have the nonce in the nonce variable. Let's update this. Something like that. And let's try it out. So we have a working exploit script at our local host. Let's try it online. Okay, sorry. Like that?
Yeah, better.
I think I spelled that right. So this should be a site that I own. We should not echo test, we should echo something more fun like the constant of database password, right? So this actually did work. From unauthenticated state, I could execute PHP to get the database password. That's pretty nice. But since we're script kiddies, right, we can reuse our payloads. So we can take this exploit that we have just written in Python without understanding how Python works. We just copy the curl command. We can just save it in the proper folder. We can reuse another tool that I have written. See if I can find it on GitHub. So another tool that I have to offload some work is HackWP. And if we use that, we can say we have a target. So what this is, for this to work, I just have to put my exploit script. I basically just have to wrap it in a function called RCE to handle the remote code execution part of HackWP. I have to put it in a folder. The attack surface here is bricks. That's a folder on the file system. So I just put it there. And then I can reuse my payloads. So when we're doing patch diffing, it's a race condition, remember? We need to be fast. That's why we need to reuse payloads. So we're testing the remote code execution. It works. The test remote code execution is just echoing two texts, this one and this one. You see them, or are they behind me? Oh, you see them. However, I have another payload called admin user. If we run that on the target, it says, okay, you now have an admin user. So I don't have to spend any time on recreating the payloads, because time is important here. I can go to the target site. It looks like this. It's a regular site. We can try it out. What was the password? Was this one? And I have a working admin user from unauthenticated state. If I run it again, it will give me another admin user, AC something. If I update, I have another admin user, AC something. Okay, so let's turn this into something dangerous. Ha 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 ha. Please don't throw me off the stage. You see where this is going, right?
Yes, I do.
Where were I? Hack WP. Okay, did I do this right? Cat and C domains, xorgs, -i%. What does that mean? Well, yeah, I made an error. No, I did not. It means, do you see this? Do I have to? Yeah, I'll do like this. Yeah. So, I have the entire zone data from SC domains, remember? I extracted the domains. There's just above 1.4 million domains in the list. If I cat them and pipe them to xorgs, what will happen? Yeah, you understand this. Xorgs will take every domain in the list, because there are on separate lines, right? And it will run this command that I have just showed you. However, I told -i%. That means whatever was in the first argument, I cat the SC domains, right? So the domain is put where I put the %. That's why I have a % here as well. Can do it maybe like this, it's easier to read. So I put the % at target, and then I just put in my exploit and I reuse my payload, and I hit enter, and I will send one request for each site in the entire SC domain spectrum. And do it, he says, yeah, I have a VPN, it's safe. It's safe. Yeah, so this will run once for every SC domain there is. There is, I think there is like 600 million com domains. And yeah, so you can basically do this for any top-level domain, and not every top-level domain will just accept that, like I did. I said, hello, I am your backup service, please give me everything. But most of them will accept, hi, I'm into statistics, please give me the zone file. They will give it to you. I tried it, they will. And this, yeah, we send this to 1.4 million sites. And according to built width, it's only just below 50,000 sites that is running this particular software as of today. So by 1.4 million sent request, I will only be admin on 50,000 sites. But, no. Yeah. But that doesn't matter, because this is a large-scale attack. I'm not targeting you or you or you. I might be targeting you tomorrow. But this is not a targeted attack. It's a large-scale attack, so I don't care. I care about the success rate. I got 50,000 new servers that I can turn to Bitcoin miners. Yeah, that's how it works. So let's go. You see, yes, can I do this without breaking anything? It's working, yeah. So Python, we have done hack WP. Do you guys have firewalls? No. Do you guys have firewalls that protects against this? Do you have firewalls that protect against some developer that did authentication based on a cross-site request forgery nonce? Developers should be free. Yeah, it's open source, right? They can do whatever they want. But in web there is like two big areas in firewalls. There's like we have general purpose rule firewall, and we have like specific rule firewall called something like, for example, virtual patches. It means you write a specific rule for the specific issue. And that, of course, will protect against something like this. But however, the general rule firewall will have really difficult with protecting against an error like this that the developer did. And if we are doing patch diffing, it's kind of like 100% the developer's fault, right? It's not like a configuration or infrastructure problem. It's a problem with the software. It's a problem with the application we're running. Patch diffing can be done on open source, like I did today. It can be done with binaries. It can be done with basically any software. It's just harder to follow. However, when we have general rule firewall, it's really hard to protect against this. And when we have virtual patch firewall, can you see my laser pointer? Yes. From what point in time do they protect? Here's the patch is released, and that's pretty much somewhere here, after the patch is released, that they can create a specific firewall rule to target this specific error, right? So there's a race condition. And if I can do this right, we have two new, way too small streck, in Swedish, streck, here. So if we can be the bad actor and we can find the one day before you apply the patch or before your virtual patch firewall can create a virtual patch, we win the race. And we really only have to win one race. You have to win this race every time. Every time there is a new patch out, it might not be unauthenticated remote code execution, but when there is, you need to win the race. If I win the race one time, your server is now a Bitcoin miner. That's why we should talk about disaster recovery. How's the time? My counter is reset here. Okay. So I will not put very much time into disaster recovery. I will just send you with a message that the security here might be based on luck, actually. If you have a domain that is alphabetically way back in the SC domain list, you might actually be safe. But it's based on luck. If you want to protect against this, your zero-day mitigation might be that we do as Dan said, we do not expose this to internet. We take it offline. Yeah, that will work. But it's hard with a website. If you want it online, you have to have it online pretty much. And we should have a plan at least for disaster recovery. And if you have one, try it out. Because sometimes if we have remote code execution, we might be able to destroy some of your disaster recovery plans. So try it out. And I had we don't have time really, I think, for a bonus hack. However, I will just raise a question for you. If we have the patch differ tool that I've just showed you, can we take the text that was outputted as the difference in the patch and put it in a publicly available AI that can understand text? Do you think it can write the exploit for us without us understanding anything? Coin toss. Yeah. So security based on luck. Yeah. There will be a lot of script kiddies tomorrow because this shit is getting better. Like the AI is getting better. Maybe it will tell you, I can do it, but I will not do it because it's dangerous. Yeah. You might have to phrase the question in another way to get it to write this for you. But my point is, I'm having the Script Kiddie shirt today, that I think there will be a lot of Script Kiddies tomorrow, and as AI gets better, this kind of attack will definitely increase as well. I think that was all I got. Thank you very much for having me.
Thank you, Emil, and super sorry for the technical hiccups. We don't know what we're doing. But Peter came to the rescue and fixed it. And for all of you who are frustrated about the flickerness and didn't have a seizure during this episode, the stream worked perfectly the entire time, so everything will be visible there. And you did great.
Thank you.
Thank you so much.